All right, here we go. It's been a couple of weeks since I filmed some videos this way, but now these videos are going to focus on preparing Calculus BC students for success. This series of questions, they all come from the 2017 BC International Exam, and this is question number 3, which is calculator inactive. So let's get rocking. The graph of the function f, consisting of 3 line segments and a quarter circle, is shown above. Let g be defined by g of x is the integral of from 1 to x of f of t dt. So I want to make sure that we're clear. This is the graph of f. This piece over here is a quarter circle, and everything else is a line segment. This is everything that they've communicated to me so far in the opening to the problem. In part A, find the average rate of change of g from x equals -5 to x equals 5. Well, average rate of change just means slope. And in a calculus class, we're going to do g of 5 minus g of -5 divided by 5 minus -5. That means I need to know the value of g of 5, the value of g of -5, and then divide all of that. Well, how do I find g of 5? G of 5 is supposed to be the integral from 1 to 5 of f of t dt. I can see x equals 1 over here, 2, 3, 4, 5. I need to find this area, which is a trapezoid, and that value is going to be 1/2 the sum of the bases, 1, 2, 3, 4. Plus that guy up there, times the height, that's a height of 4, so that looks to be 4 plus 2 is 6, half of that is 3, times 4 is 12, g of 5 is 12. G of -5 is the integral from 1 to -5 of f of t dt, and depending on your comfort level, you might want to switch your limits of integration to say that now those limits are from -5 to 1 of f of t dt. That's legal to switch the limits of integration, but make sure you introduce that negative sign. And now you need to find the area from -5 to +1. All right, let's do that. So find -5 on the graph, -1, -2, -3, -4, -5. You need to find the area all the way from x equals -5 to x equals 1. I see a triangle here. I can find the area of that triangle pretty easily. The base is 3, the height is 4. Half the base times the height is going to be 6. I have a quarter circle over here, and so that is going to be 1/4 of pi times the radius squared. The radius is 2 squared. And the area for this little triangle over here is again 1/2 base times height. The base is 1, the height is 2. Multiply those, cut it in half, and that's going to have an area of 1. Now, I want to make sure I don't blow it here, because all of these areas that we just calculated are all below the x-axis, so the 6 is a negative. This 1/4 pi times 2 squared is a negative. That 1 is going to be negative. So the whole thing, if I distribute this negative through, I'm going to get 6 plus 1/4 pi times 2 squared is pi, plus 1, that looks to be 7 plus pi. Whew, that was a whole lot of work. So g of 5 is, what do we decide that was? 12. G of -5 is 7 plus pi. And we're going to divide that by 5 minus -5, which is 10. Because everything here is a number, you can stop, or you can simplify. You can distribute the negative through, and you're going to get 5 minus pi over 10. My preference would be to stop in the very beginning. In terms of how they awarded the points, as soon as you wrote g of 5 minus g of -5 over 5 minus 5, this is called the difference quotient, you earned the first point. So that is a pretty friendly point to earn. All of this work that we did getting over to here Got you one more point. That was a whole lot of work. So that's a grand total of 2 points in part A. Oof, we had to work for that one. All right, let's keep going. Part B. Find the instantaneous rate of change of g with respect to x at x equals 3, or state that it does not exist. All right, let me fold up some of this work. Okay, let's just ignore that. The instantaneous rate of change of g, well, that's just the derivative with respect to x at x equals 3. Really what we want is g prime of 3. Well, what do we know about g? We know that g is the integral from 1 to x of f of t dt. To find g prime of 3, this is a two-step process. First, you find g prime of x, which is the derivative of this integral of f of t. And I hope we've done enough of these at this point that you know what to do. The derivative of the integral of a function from a constant to a variable, all of that is just your integrand evaluated at the new variable. This here is your second fundamental theorem of calculus. So we've just established that g prime of x is equal to f of x. So g prime of 3 is equal to f of 3. To find f of 3, I'm going to go over to the table. 1, 2, 3. I'm going to go up, and it looks like f of 3 is equal to 4. And they awarded 1 point in part B. Yep, that was a whole lot of work to get that one little point, but not too bad. Let's keep going. In part C, we're asked the question on what open intervals, if any, is the graph of g concave up? Well, remember we've already established that g prime and f are the same thing. I want to make note of that. If g is concave up, then what that means is that g prime is increasing. And if g prime is increasing and g prime and f are the same thing, then this means that we're looking for where f is going to be increasing. Because I have the graph of f in front of me, I can answer this question relatively easy. Where's f increasing? On what open intervals are we looking at? I can see that my graph of f is going to be increasing starting at x equals -5. And we increase all the way until we get to -2. Now we're decreasing on this interval, but then we start increasing again at 0, and we continue increasing until it looks like that is going to be 3. And that's it. 1 point for making the connection that g concave up means g prime is increasing, which gets you to f is increasing. 1 point for the identification of both intervals, for a grand total of 2 points. And just a quick note, I was looking at the scoring rubric back in part A. Let me go back to part A, and I lied to you all. My apologies. There was 1 point for the difference quotient, and then 2 points total for all of this calculation and coming up over here. So it's a 3-point question. The College Board doesn't say exactly where the first point comes in, but I would assume that if you correctly found g of 5, or if you correctly found the value of g of -5, that would probably get you the first point, and then that next point comes in by pulling it all together. Sorry if that wasn't clear the first time through. Okay. Part D. Find all x values in the interval -5 to 5 at which g has a critical point. We'll talk about that in a second. Then classify each critical point as the location of a local max, a local min, or neither, and justify your answer. So here's what we need to keep in mind. When you say a function has a critical point, that means that either the derivative is equal to 0 or the derivative is undefined. If either of those two things happens, then you're gonna call that point a critical point. Well, what do we know? We know that g prime of x and f of x are the same thing. So if g prime is equal to 0, that means that f of x is equal to 0. I can look at my graph and I can see that this happens at x equals -2 because we have a root, and also at x equals 1 because we have another root. Let's see, is g prime of x, which is equal to f of x, ever undefined? On this particular interval, the function is always defined, so this is actually not something that we need to worry about. So we're not going to have any critical points coming from this idea that g prime or f of x is undefined. So that's good. We just need to worry about what happens at x equals -2 and at x equals 1. Well, what happens at x equals -2? At x equals -2, before x equals -2, I can see that g prime, or f, is below the x-axis, and then continues to be below the x-axis. At x equals -2, g prime does not change sign, which means neither a max nor a min. However, at x equals 1, g prime, which is equal to f, makes a change from being below the x-axis to above the x-axis. So g prime changes from negative to positive, which means that g has a relative minimum at x equals 1. And I just want to compare all my work to the scoring rubric here. Okay, they say 1 point for considering g prime and f of x being equal and being equal to 0. It then says 1 point for identification of your critical points at x equals -2 and x equals 1. And then your third point comes in here for the determination that at x equals -2, it's neither a max or a min, and there's the explanation. And at x equals 1, g prime changes from negative to positive, so you have a minimum. So a grand total of 3 points. 2 of them we locked in really quickly. Okay, that's about all there is for this question. 1 down, 5 more to go.